Welcome everybody. This is the walkthrough series for the 2024 Codebreakers. In this series, I'll be going through all 9 challenges, starting with task 1 and then working our way through all the way to task 9. This is going to be a overview and broad analysis of every challenge, so don't expect everything to be fast and just jumping straight to the point. With the harder challenges, I'll try and give a quick TLDR on what the solution is, like challenge 8 and 7. Other than that, we'll just jump right in. So for those of you that don't know what Codebreakers is, but most of you that are here should, it is a yearly simulation kind of event handling a bunch of different topics in the cybersecurity realm. And this year we have this topic detailing a simulated exfiltration of data and exploits happening on a network. We're trying to interact with the affected hosts and try and find the path that everything is going through. So starting this, we'll just hop into task 1. A little bit of the background, purely fictional, for educational purposes only. Nothing else with the kind of scenario except for right here. The U.S. Coast Guard discovers an unidentified signal near U.S. waters. Our role is providing technical assistance to the United States Coast Guard to identify and investigate the unknown object producing the signal. So task 1, task 0 is just having you hop in the Discord. I'm going to ignore that one for now. But with task 1, we're going to try and find the unknown object. It's general programming and database retrieval skills. But the U.S. Coast Guard recorded unregistered signal over 30 nautical miles from the continental U.S. NSA is contacted to see if we have a record of a similar signal in our database. The Coast Guard provides a copy of the signal data, and it's our job to provide the USCG including records from the database that could hint at the object's location. Per instructions from the USCG, to raise the likelihood of discovering the source of the signal, they need multiple corresponding entries from the NSA database whose geographic positions are within 1/100th of a degree, and additionally recorded timestamps should be no greater than 10 minutes apart. The big takeaways from here are 1/100th of a degree and that the timestamps are less than 100 minutes apart. Other than that, we should be able to hop in, just download the 2 files. All this is in a completely, if you want to work along with, all this is in a completely brand new Kali VM. I'll just be going through the files that I was given for my scenario. I don't think I'll host them anywhere, just in the process of trying to keep it fair for future events, but yeah. So I'm going to make a directory, Codebreakers. I'm just going to make a directory called 1, just go through the challenges one by one. I'm going to move the files, not mount, in home, downloads, I think there should be only 2 in there, into this directory. So now we have 2 files. If you don't know what any of these are, we can always just open them with the cat command. So the log appears to be our starting coordinates and our starting timestamp, important for us to know. And whatever this database file is, if you don't know what that is, it looks like a bunch of database data. If you don't know how to interact with it, a file command might give you some information. We can see that it's an SQLite3 database, or just a database file in general. So we can use the SQLite3 command to open this guy up. And we could do .schema to dump the information from the database. So we can see we have several tables. We have audio object, SQLite sequence. I think that's just a normal table in the SQLite database. Location, timestamp, and event. And what's important to us probably be just the location and timestamp, as that appears to be, if we look back at what we need, we just need the record IDs, 1 per line, that fit the parameters. So given our starting time and location, we really only need the timestamp and location. With that said, we're going to then, I'm going to open up a new terminal. Does Python 3 come installed? Do we have SQLite 3 in here? Perfect. What I'm going to use is I'm going to create a Python script to help us finish this challenge. SQLite 3. If you don't know what the SQLite 3 library is, you can always just search it. SQLite 3, Python 3, if you don't know how to open it. And we can see we have a link right at the top that gives us a bunch of commands. And more or less, I'm just going to actually copy all of this. This will allow us to get a good start on what we're looking for. Paste that in. Don't actually care about this other stuff. And then we'll have to change these commands around first. Come up here, we're actually going to go into database.db. Now, if you're not sure what commands you want to run, it's not a bad idea to just dig around within the SQLite command itself. So we can do something like select everything from the location table. And that's probably all we really want for this. There's two ways to really go about this. You can go about the location or the timestamp. I think location is slightly easier, uses less code. So I'm going to go with that one. So through our execute case, we're going to go select everything from the location table. I'm going to save that to res. Nope, save that to, yeah, I'm going to save that to res. Don't actually need this one, that's just a copy of this line. We're going to do .fetch all though. So what fetch all does is it will grab every single line. There's also fetch one. If we look back here, so there's a fetch one, which just grab the first item, whereas fetch all should go through and grab them all. And if we want to confirm this, we can print it out to the console to make sure everything is working before we go on. Looks like I should probably call this method. And you see here we have a list or table of all the entries. So now we can just go through them all. So for x in res, we got to do something. So what we want to do is compare these values to our starting location. If we remember, our starting location is found at 27.5.522. Do lat equals this, longitude equals this, and then we want to do something within here. So what we wanted to do, since we're doing the lat and longitude version, if we go back to our checker, we can know that if we're within 100th of a degree, it's probably fine. So if you want to do a very in-depth program, you probably should check to see if you find a value that's added to a list, and then compare those values, see if there's any buoys within those or connected to those within a certain area or time. But with our very small number of entries, I can guarantee you that there's not really that many values that actually intersect with our 1/100th of a degree, so we don't have to worry about buoys next to other buoy check marks. So I'm going to grab a temp lat, which is equal to x at 1. If we remember, it's just going to grab since our entire index or row is grabbed like this, index 0, since it's going to be a list of lists. Index 0 is going to be the first index. Index 1 will be our latitude, so index 0 will be the ID. Then we go latitude, and then longitude, and then our altitude, which are all 0 in this database, so that doesn't really matter. But we want 1. You need to make sure that you convert this to a float, as this will be stored as a string. Before we go on, I'll just print this out to prove everything. Whoops. We'll just print out one of them. We can see here we have index 1, or ID 1, this is actually a tuple, so it's not a list. Our index 1 is then the latitude, index 2 is then the longitude, so we can compare those. Temp lat, temp lon is equal to the float at x of 2. Then we can just do an if statement to see if temp lat is greater than equal to our lat at minus 0.01, so this will be our bottom check, and our temp lat is less than or equal lat plus 0.01. Then we can do something. That should be our check to see if we're within the latitude range. Just put some parentheses around that so we know they're separated. And then do and on the new line we'll do if our temp lon is greater than equal to lon minus 0.0, and our temp lon is within that same range on lon plus 0.01. I think that should be it. I'm actually going to change this to an OR instead of an and. Technically, if we want to make sure both the lat and lon are within the same range, we should do and. But I'm going to do an or just to make sure it's a little bit fuzzier, has a little bit more give. And so we just print x and see what we come up with. I think that should do it. So we have 2 entries. Just to make sure that we're actually correct on these, we're going to go back into the database. And we're going to do select everything from timestamp, I think. Let's do a dot schema again, just to make sure. Yep, timestamp. So select everything from timestamp, where the ID is equal to 614. We'll just check to see if these times are within our range. We can see that this one is at March 8th, 2023 at 2 p.m. it looks like. And if we look back to our original, March 8th, 2023 at 1:55, which is within 10 minutes. So that should look good. And we can also do the same thing for 8:39 and see that this is within 10 minutes of this one. So that's a very good chance that these are the 2 values that we're looking for. So if we do 6:14 and 8:39, we can check to see if those 2 are correct. And look at that. That's task 1. Please come back for the other task if you're looking for some more information about this challenge. Yeah, hopefully you enjoyed and learned something new.